We've been talking about how to find the zeros, so using the equation, setting equal to 0. Now we've got a couple word problems to look at. A multi-level driving range has 3 levels. Marco hits the golf ball from the 2nd level, which is 32 feet high. The height of a ball, x seconds after Marco hits it, is modeled by the function h of x. When does the ball hit the ground? Thoughts here?
Well, we can divide everything by -16.
Okay, that'll be a key point in a moment. Hold on to that thought. I like that thought. What do we have to think about in terms of when does the ball hit the ground? Because right now we have this function, h of x equals -16x squared plus 16x plus 32. It tells us it represents the height of the ball x seconds after he hits the ball. Y equal to 0?
Because your 0 is your second.
If you're going to be putting it equal to 0, and if all else fails, that's what we were doing yesterday, was putting things equal to 0, yes. But why? Because what that means is I'm making h of x 0. Why am I going to make h of x 0? What's the question asking? When does the ball hit the ground? And what do we know about the ground?
We don't. 32 feet. No.
Well, you're starting at 32 feet, but the 32 feet is represented in the problem. What do we know about the height of the ground? The ground has a height of 0, yes? That is our base. So when it's asking when does the ball hit the ground, we're being asked when does h of x equal 0. Okay? Which, again, that's what we want. We want this equation equal to 0, but you don't get to randomly just set it equal to 0. If this says when is the ball 100 feet off the ground, then we have a different situation. Okay? So we are going to take our equation of h of x equals this function and set equal to 0. So we're going to have 0 equals -16x squared plus 16x plus 32. Now, let's talk about what Patrick noticed. Okay? Everything nicely divides by 16, and even better yet is a -16. Okay? Now, we can do this one of 2 ways. Because it's an equation, you can divide both sides by -16, or we can factor out the -16. Either or. I think since we've been factoring, I'm going to show factoring in that if we divide, or if we factor out the -16, -16x squared divided by -16 leaves me with 1x squared. 16x divided by -16 is going to be -x. 32 divided by -16, -2. And I just flipped my equal 0 down to the right. Okay. That -16 is just a factor. It's a number. It's not going to mean anything. What do we need to do with what's left inside the parentheses? Yeah. Can we jump straight to 2 parentheses? Yeah, we can, because it is 1x squared, right? Because we're at the point we have 1x squared, we can think x times x. And we need numbers that, what? Multiply to be, okay? What multiplies to be -2 and adds to be -1. Okay. And if all else fails, I know it's some combo of 1, 2, yes? 1 times 2 is 2. And if it multiplies to be negative, one of them's negative. It's adding to be -1, so we are going to have a -2. Now what? Okay, set each factor equal to 0. Now, the -16, if it had a variable, I'd want to set that equal to 0 also. Because it's just a number, -16 equals 0, that's just irrelevant. You're going to worry about the pieces with x's. So x plus 1 equals 0, x minus 2 equals 0.
equals -1.
X equals -1, and x equals 2 when we do the solving. Okay. What's my answer?
-1 or 2.
Yeah, plug it back in.
Well, if I plug them back in, they're both going to give me a height of 0. So they're both going to give me times when the ball hits the ground. What's my label on these answers then? Seconds?
Yeah, that's what it seconds.
So my answers are -1 second or -2 seconds? Or excuse me,
Oh.
-1 seconds or +2 seconds?
It'd be 2 seconds.
Are you seeing the catch here? We're in a word problem, yes?
Yes.
When you're in a word problem, always evaluate the validity of your answer. Is -1 a valid answer here? Not when x represents seconds. Okay? So right there, we can't have a negative. Okay? That's the problem. Does 2 seconds make better sense? Yeah. Okay. So, when does the ball hit the ground? The ball hits the ground 2 seconds after Marco hits it. I'm going to write that out real quick. Ball hits the ground 2 seconds after Marco hits it. Okay? So, word problems, always check what your answer is, what it means, does it make sense, is it logical? Negative answer doesn't make sense when we're answering time. Just like it wouldn't make sense if it was the height. Okay, questions on that one? Okay. A baseball is thrown from the upper deck of a stadium 128 feet above the ground. The function, h of x, gives the height of the ball x seconds after it was thrown. How long will it take the ball to reach the ground?
Drop my phone.
What do you see here? What do we notice? The question is, when does the ball reach the ground? So what do we need to consider? What do we know about the ground?
It is 0.
Okay, the ground is 0, yes? Okay, the ground is a height of 0. So we're looking for when the ball is at a height of 0. So, like last problem, replace h of x with 0, right? So we're going to have 0 equals -16x squared plus 32x plus 128. Okay, where do you want to go to solve this? What you figure out? Yeah, does 128 divide by 16? It does. So can we divide everything by -16 again? We can, right? Look for those nice little tricks. So if I factor out a -16, no, I was going to move that 0. If I factor out a -16, -16 x squared divided by -16 leaves me with x squared. 32x divided by -16 leaves me with minus 2x. 128 divided by -16 is it 8?
Yep.
Minus 8. And again, this equation equals 0. We've got that -16 out front. Again, what I'm factoring starts with a 1x squared, right? So take advantage of it being an easier factoring problem. 2 parentheses, x squared breaks into x and x. I need numbers that multiply to -8, add to -2.
So, 2 -2.
Okay, some combination of 2 and 4. Can we at least agree there? Yes? That's always my thing. Get the numbers, and then we'll figure out the signs. If it multiplies to be -8, one of them's negative. If it adds to be negative, I always say the larger number is negative, and then that makes the smaller number positive. Set each factor equal to 0. So x plus 2 equals 0. X minus 4 equals 0. Okay, if you subtract 2, x equals -2. If we add 4, x equals 4. So what do we know?
It'll take 4 seconds for the ball to reach the ground.
Okay. Does it also take -2 seconds?
No.
No. Again, this is a negative, folks. That rules out the answer in this type of word problem. Okay, so the question was, how long will it take the ball to reach the ground? The ball reaches the ground 4 seconds after it was thrown. Always be able to label your answers, folks. I'm not saying you necessarily have to write out the explanation that I wrote out, but can you at least label it? Get the 4 seconds on there. Okay. One last topic for today, or for this lesson. And it is yet again writing an equation of a parabola. However, this time it's writing an equation of a parabola in factored form. Okay? So a little bit different on what the information is that's provided. Write an equation of a parabola with x-intercepts at -2, 0 and -1, 0, and which passes through the point -3, 20.
I have no idea where to start.
Okay. I will say a big clue here is that we're writing this equation in factored form. So it's not going to be like our ax squared plus bx plus c. We are going to think of it in terms of factors. It's like what we've been breaking into x plus or minus a number times x plus or minus a number, right? Okay. Now, I'm going to give you a basic form that the book uses. And the book uses the form y equals a times x minus p times x minus q. Okay, that's the basic form the book uses. And that is where p and q are x-intercepts. Okay, so that's when you're asked to write an equation and they provide you with some intercepts, some x-intercepts. Okay, we talked about x-intercepts yesterday, right? Where the graph crosses the x-axis, it's also our zeros. Okay, what do we know here? Okay, we have two x-intercepts provided? Yeah. We have x-intercepts at -2, 0 and -1, 0. Where are -2 and -1 going to go into my equation for?
Wherever you want.
Not just wherever I want, but these are going to be P and Q. Because those are my x-intercepts. Remember I showed you on that front page of the notes how x-intercepts, zeros, same idea? That's where these are going to go in for. So they're going to go in for P and Q. So what I know right now, y equals, now, the thing I don't know yet is A. We'll have to come back and talk about A. X minus P, so X minus one of our x-intercepts, which I'm going to say X minus -2, x minus q is x minus the other x-intercept, so x minus -1. So, right now we have y equals a. What do you know about minus -2? It's x plus 2. X minus -1, x plus 1. We can't stop here. We need to know a. X and y are good. They're the variables in the equation. We've got our p and q filled in. How do I find a? Are we using all of our provided information?
There's the point that it crosses through.
Yeah, we're also provided this point, yes? What do you know when you're provided a point? Probably use it. What about any ordered pair? There, what type of values?
X or Y.
X and Y? Do you see where I'm going with this?
There's no A.
No.
But we can use that X and Y to find A.
A.
Okay, so the idea here is I can put, what is my X value? -3. So I can put -3 in for X. What is my Y value? 20. So I can put 20 in for Y. And I can use that to find A. So 20 equals A times -3 plus 2 times -3 plus 1. Do some math, right? 20 equals A times -3 plus 2 is -1. -3 plus 1 is -2. A times -1 times -2 is
2A.
2A. So I have the equation 20 equals 2A. If 20 equals 2A, what do we know? Divide by 2. And A is 10. Now can we write our final equation? Yeah. We had it pretty much set up right here, didn't we? But we still needed to know A. So now we can write our final equation using that original form. Y equals A, which is 10, X minus P, X minus -2, which we wrote as X plus 2, X minus -1, which we wrote as X plus 1. You get to leave it like that. They ask you for your answer in factored form. They don't want you to multiply this together and get to standard form. They want you to leave it like this. So we're going to take advantage of it when they say that, right? I don't want to do the extra work. We're going to stop there. Okay? So, not the question we see a whole lot in terms of writing it in factored form, but that is the process. So, basically remember that your x-intercepts go in for zeros, but you do have to check and see if there's an A value out front. So you do have to check that. We can't just assume that the A value is 1. Might be in a case, but we can't assume that. Okay. Try one more. Write an equation of a parabola with x-intercepts at 3, 0 and -3, 0, which passes through the point 1, 2. So again, using that original form, y equals A times x minus P times x minus Q. What do I know? P and Q are 3 and -3. So, and you can jump right in. I'm going to take it in steps here. So I have y equals A, which I don't know yet, x minus p, x minus 3, x minus q, x minus negative 3. Okay. So right now I have y equals a times x minus 3 times x plus 3, yes? Minus negative 3 is plus 3. What do I know? In order to find a, we can use our other ordered pair as
1, 2. All right, y.
x and y. Okay. It's just some random point, and they give you that some random point, think x and y. So if it's y equals, I'm going to say 2 equals. And every place I see an x, I'm putting in 1. So 2 equals a times 1 minus 3 times 1 plus 3. Two equals a times 1 minus 3 is
-2.
negative 2. 1 plus 3 is 4. Negative 2 times 4 times a is negative 8a. I think I'm going to bring this one over. So I have negative 8a equals 2. What do we do to solve?
Divide by
Divide by negative 8. And if we divide by negative 8, what is a?
-1/2.
1/4.
Negative 1/4? Okay. And I would just leave it as that fraction. Yes, it is negative 0.25 as a decimal. I'm going to go with a fraction for this. Okay. Write your answer, yes? Y equals, we now know a to be negative 1/4. We had x minus 3 and x minus negative 3, which was x plus 3. Okay? Okay, guys. That's the other piece here. Whole lesson focuses around factoring. Okay, so we've got to walk out of this lesson being able to do our factoring. We do have one more page in 2.3, but it's 2.3 part 2. And we'll talk about determining positive negative intervals, but we'll save that for tomorrow. So, get logged into Savas and get working.